It is okay to say stuff like welcome to our Gearfest booth. My name is Bob and I'm the director of sales for XYZ company. You know what I am saying. I'm going to walk you through some of the most exciting products we have here at Gearfest 2020.
This is our example for a dedicated drum synthesizer, and we've built it around this trigger matrix. We've added the ratcheting controller, which is good to make drum rolls and also to have a source where we can control the speed of the happening with an incoming voltage. So it really completes this setup. Otherwise, the system is built on a 4-voice idea. So we took the quad decay, the quad VCA, and down here we have all the modules that make the voices, and we have 2 oscillators. The ring modulator, digital noise, SAM type filter, noise random module, SAM type filter, A106. Then we have the LFO and another filter that goes usually along with the BBD. To filter its output and to hear the noise that comes from the BBD when it's really fast. And I think we hear in the examples that it's really worth thinking of drum computers in modular. Here we have a polyphonic example of a system that we mounted up. As Dieter has released his polyphonic modules just recently, and according to himself, his idea was to enable users of modular synthesizers to realize polyphonic structures, however this may look finally. And so in the first go, he came up with several modules. One was the quad oscillator, which is effectively 4 times the high-end voltage controlled oscillator 2. So it's a very good oscillator. Of course, he had to strip down a bit on the sockets and everything to make it more compact. But on the backside of this guy, we have a lot of jumper options. So it integrates really quite well. Then we have the first polyphonic filter. I believe there's another one to come to complete this, because here we have a low-pass filter only design. Then we have the octal poly VCA, which is actually very good because it's one of the rare VCAs in Eurorack format that features velocity inputs. Then we have the quad poly voltage controlled envelope generator. It's same as complete, if you want to say, as the VCA, because it features voltage control with attenuators for all the 4 phases and super compact. then we have the noise and random to give some flavor to the patch, and a second ADSR module specifically for this patch that we can use it with the filter, and one with the VCAs. A second filter was added, a multimode filter, to have a high pass at least on the sum, and then we've added a voltage controlled LFO to complete it. And then you can hear the sound examples that we patched to get an idea of how this baby sounds.
Now let's have a look at the Doepfer Slimline modules, small and affordable Euro-rack modules with a great sound. Yeah. Let's make some noise-based percussion sounds. Therefore we need a noise source as our foundation. I take the colored noise output from this Doepfer module, plug it into the filter input here. We take a high-pass output, go into the VCA. From the VCA to our oscilloscope over here. And now if I open the VCA, we are able to hear our noise. And filter it with the filter. And shape it with the blue and red knobs on the noise module. So I turn the gain down, because now we use the MIDI sequence that is coming through this USB cable to our MIDI interface. And we can see the LEDs on the ADSR are flashing. They receive the gate information through the CV and gate bus. And we can use the outputs here, our VCA, and the second output of the first ADSR on the cutoff input for the filter. Furthermore, we can make use of the velocity output on the MIDI interface. Therefore, we need a second VCA. So I take the output of the first VCA, plug it into the input of the second VCA, and then again to the oscilloscope. And now with the velocity output on the MIDI interface, and the gain turned down here, we have a velocity sensitive percussion sound. Now let's build a bass drum. We use a micro VCO here from Doepfer for generating the triangle wave, and I send this directly to the oscilloscope here so you can see and hear it. But we will have to get it through a VCA. What else do we need? We need these two envelopes, one on the pitch of the VCO, and I use this input here, the exponential, because we can scale it here, and then we can send the signal from the VCA, to the oscilloscope, and of course we have to send the second envelope here to open the VCA for us. Here we are. So with only 1, 2, 3, 4 cables, and obviously the Doepfer CV gate bus, we created a kick drum. We can play around with the parameters here. Some softer and some a bit harder. Thanks for watching.
Information, contact your Sweetwater Sales Engineer.